Ladies and gentlemen, times are changing. The EPA has been increasing their demands to create engines that emit less and are more efficient, so auto manufacturers are forced to respond to that. This requires more direct control of the combustion process, and therefore engines that emit less and use less fuel to make the same output. So what we have here is a Gen 4 engine, and that is would have appeared in vehicles from 2006 to 2014. This particular one is a LH6 or an LC9, I'm not 100% sure on that. And then on my left here, we have an L83. This is a Gen 5 Chevrolet V8. So this is they're both 5.3 liters, but you will notice very significant differences across the two of them. So right off the bat, you'll see the cylinder heads have been significantly altered. So this is one of the most exciting parts of the changes. So you'll notice the old cathedral style intake ports here. These particular cylinder heads are 799 LS cylinder heads. And on the L83, you'll notice these square port, much higher in the cylinder head, and that allows it to get a better angle on the valve and thus flow more. So if you're familiar with the older, this would be considered an LT style engine. If you're familiar with the older Gen 2 LT engines, when they did the LT1, they had a port that may have been a bit lower, and then they put the high output LT4 engine out, and they raised the intake port, thus increasing cylinder head flow. So what you'll notice with these intake ports is they're massive. I mean, these things are huge. If you compare them to the 6-liter LS3 style cylinder heads that would come on the LS series engines, you'll see that the intake ports are actually pretty similarly sized. So typically you wouldn't see such a large intake port on such a small engine. But GM has found a way to make it work. They're, as far as head flow goes, they don't flow as much on the flow bench. But what I can tell you is they work way better. It's not all about head flow on the flow bench. So that's one change. Obviously, you can see the valve covers are very different. They have built-in baffles in here to help with scavenging. Another change up here on the top is you will notice that the injectors are not in the intake. They are right here. They go directly into the cylinder. So this is what is called direct injection. So this is the part that, well, one, the cylinder heads, I'm really excited about that. But this is my second part that I'm most excited about. So this is gives you very direct control of the combustion process. So this allows you to basically, you can run way leaner air-fuel mixtures and pick up lots of power, because if the fuel's not there, it can't knock. You know, it can't pre-ignite the fuel if there's no fuel. So with this, you can run way leaner air-fuel mixtures, which picks up a bunch of power. You can play with injection timing and all sorts of things like that. So one of the requirements for that is you need a very high pressure system here. So this is probably around 3,000 psi, I believe. And what they require for that is a high pressure pump, which is driven off of the camshaft. Now this is just the roller that rides on the camshaft that drives the high pressure pump. I don't have the high pressure pump. This is how I bought the engine, so some of the parts are missing, as you can clearly see, But this little roller, there's basically a triangle roller in there, and it actuates this high pressure pump and makes the high pressure fuel that is needed to get the fuel into the cylinder, which may be at a very high pressure, as you can imagine. So we're going to start taking these apart. I'm going to point out any differences that I see. I guess I'll point out more differences up here in the front. So you'll notice that they changed the water pump mounting flange. That's one part that kind of annoys me, just because if there's no reason to change it, why change it? You know, why not make it so that all the parts from an LS bolt to an LT? But I won't harp on that too much. So yeah, that's completely different. You'll notice very similar VVT type setup across the two engines. Another extremely annoying change is they changed the motor mount flange. So they went to a wider bolting flange, and I believe it's further back. That or forward. It almost looks further forward. But that's very annoying because that means you need to make your own specific mounts or buy adapter plates to put this in place of an LS engine. So let's take off the valve covers and we will continue to find more differences. Alright, one difference right off the bat is you'll notice the valve covers are significantly different. So on the LT, you'll notice that there are perimeter style fasteners, and on the LS, the fasteners go through the center of the valve cover. Also on the LT, you'll notice that the baffle system is significantly different. It encompasses the entire valve cover. I imagine that is to reduce losses due to windage. So that's one change there. So right off the bat, you're going to see I don't have any rocker arms. This is the way I received the engine, so you're just going to have to deal with it. But you'll notice that the LT does not have bolt-on style rocker stands like the LS does. And you'll also notice that they are at different angles. So similar to a big block Chevy, the LT features canted valves. So the valves are at angles, and therefore you can get more of the valve and basically allow less shrouding of the valve to get more air into the cylinder. So there are 12.5 degrees roughly on either valve, and because of that, the bolt-on rocker stands weren't really going to work, I imagine. That's why they did it. And also, you will notice that the intake ports are very, very raised, very dramatic angle. So that's like that's like race car stuff. This is like SB2. Like, if you guys know what that is, it's like the NASCAR engine, NASCAR version of like a small block Chevy. So if we come over to the LS, you'll see the intake ports are much lower, and we have these rocker stands which are removable, and they're all parallel to one another. So that's one significant change. One other thing, another annoying thing, the bolt pattern for the exhaust manifolds is different. So they changed that from what the LS had, and also you will notice that the bolts are offset downwards on both the front and back. That means you cannot flip the exhaust manifold 180 degrees. You can change them side to side, but you cannot flip them 180 degrees and have them facing up to do like a turbo manifold. Very annoying. You may be able to re-drill the holes, but some stuff like this, good job, GM. That, come on, like, it's so simple. But you know, you got to take what you can get. So let's move on to taking the cylinder heads off, and we can show you what these pistons, and that's another very significant change. So let me blast those off and we'll show you the difference. While I was taking the cylinder head bolts out of the engines, I wanted to make sure I mentioned this. So many people on the LS, they are taking their engines and they are chucking them up into a milling machine, and then they are drilling or using a fixture plate, and they are drilling out the threads in the block to go to a 1/2 inch head stud. So if you don't know, 1/2 inch is like 12.7 millimeters. So in the LT, they basically already did that for us. So in the LT, they went to from a 11 millimeter fastener in the LS to a 12 millimeter fastener. Sure, it's 0.7 millimeters short, but you can see that it is a much finer thread, which will allow you to clamp the bolt down more, and it's a larger fastener. So what my opinion is, if you're building an engine and you're really going to start pushing it, rather than going to a 1/2 inch head stud on an LS, why not go to the LT with the much better heads, and you already have the upgraded fastener. So I'll keep blasting these off, but just thought I'd mention that. Thought it was a very good thing to know, and let's get back to work. Alright, more changes. So you'll notice that the pistons on these engines are very different. So on the LS style engine, they're more flat top with valve reliefs, and on the LT style engine, you'll notice that the piston is raised and there's this little area right here. So what this is, this little cup here, basically when the direct injector sprays into here, what this is meant to do is reflect the fuel and get it to spray up onto the spark plug during a cold start situation. So this, from what I've read, is literally, this is only for cold start. It has no other purpose. You know, you can put flat tops in here, you'll be fine, but the only thing you have to be careful about is these engines have piston to valve clearance issues. Basically, when you put a larger camshaft into this engine, you will run into piston to valve clearance issues sooner than you would on an LS. So you have to be careful. Got to make sure that if you put an aftermarket piston into this engine, it has the appropriate valve reliefs. Also, since this part of the piston is raised, it's higher compression. So I believe these engines are around 11.5 to 1, if I remember right. Whereas this guy over here, he is around 9.5-ish. So significantly raised the compression because, again, if the fuel is not there, it can't knock. So you can run a higher compression piston and basically wait until you're on the compression stroke to start spraying the fuel, and it will not auto light the fuel and air mixture because there's no fuel. So that's one of the biggest advantages to direct injection, in my opinion. You can run way more aggressive timing and fuel because it can't knock because there's no fuel. So another change here, which you cannot see, which has been found out already, when you push a stock bottom end, the pistons are set up with a low tension ring. So that's like a very high output, naturally aspirated type thing. And the consequence of that is the low tension ring causes less drag and basically allows you to make more horsepower, or the same horsepower with less frictional losses. So that's annoying because when you add boost, it's not set up for that like an LS is. The LS will just eat the boost, you know, doesn't care. With the low tension rings in the LT engine, what you run into is that low tension ring will start to flutter, and then it'll break a piston and ruin your day. So what my plans are with this guy is I want to take these pistons out and take the top ring off and take it to a buddy of mine and see if we can find a non-low tension ring for the piston that will drop in, and I can use the stock pistons with a non-low tension ring and run lots of boost, and hopefully we never have any issues. All that being said, if you guys follow Faster Proms, he's another YouTuber, a lot bigger than me. He is pushing one of these engines to around 800 wheel horsepower. And what's most incredible about his combo, and why I even have looked at these, is because of his development on them, is he has a twin turbo S10 with 9 pounds of boost. He's making 800 wheel horsepower. Now, going back to the LS series engines, a 6-liter, my 6-liter in my Fairmont with twin turbos, tons of exhaust flow, we're not dealing with any back pressure, to make 800 wheel horsepower is like 17 pounds of boost. And that's a 6-liter with square ports. And he's doing it on one of these little 5.3s with 9 pounds of boost. So, obviously, these things work. Alright, so on the front of the engine, you will notice that they went to a different seal type on the timing chain cover. Rather than doing this O-ring type gasket, they went to a silicone setup, and they actually doweled the timing chain cover, as you can see right here. I'm actually a pretty big fan of that. With the LS, they actually sell like alignment tools and that kind of thing, so that you can align the timing chain cover with the bottom of the engine and make sure that your crank seal, your crankshaft harmonic damper seal here, is perfectly aligned with the center of your crankshaft. Whereas on this, it has dowels, and it's machined to a higher tolerance, and you just install it. You don't have to think about it. So that's kind of cool. But also you will see that it is the same but different. So the Gen 5 engine obviously has variable valve timing. That's what this guy is here. I'm missing some parts, but you get the idea. But you will also see this monstrosity of a oil pump versus the one seen on the LS. So that has to do with the fact that that thing is electronically controlled. So they are electronically changing the output of the oil pump with this little solenoid right here. And that makes it a little more annoying for us LS guys that may be converting. You may be doing port injection on the LT engine to start off, but you have to make sure that you do your research and figure out how that little solenoid affects the output of the oil pump. So next I'm going to pop the cam out. We'll show you the fuel lobe and just show you the differences on that guy. Alright, so now that we have the camshafts out, you can clearly see the high pressure fuel pump lobe that I was talking about earlier. So it's a triangle shaped lobe, and it just obviously actuates the pump 3 times per revolution of the camshaft. So there's that. But other than that, they're actually pretty similar camshafts. The one difference that's very annoying is GM changed the port configuration on these engines. So instead of on the passenger side cylinder head, the first port being the exhaust port, On the LT, the first port is the intake port. So you'll see the very first valve as you move from front to back is an intake port. Whereas on an LS, the very first port as you move back on the cylinder head is an exhaust port. This means that the camshaft is significantly different. Instead of this first lobe here being an intake port like it is on an LS engine, it is an exhaust port on the LT. And as you can imagine, that has a very significant effect on the camshaft design, because these have to be timed such that they're intake or exhaust lobes. So yes, they look very similar. As you can see them sitting next to one another, they have the oil passage here for the variable valve timing. They look very similar, but you can see the lobes are totally different. One other change here is they had to move the rearmost camshaft journal a little further back because they needed to fit the fuel lobe on. So the camshafts do not interchange. They might be the same diameter, but they are very different design. So there's no way of like taking the L83 bottom end and putting LS heads on it to take advantage of like the 12mm head studs and the piston oil squirters that we'll show later. There's no way to do that and use like an LS camshaft. That also means you cannot use LS camshafts in the LT engine as an upgrade because all of the valve order is different. So you have to get a one-off LT style camshaft if you're doing a camshaft upgrade on one of these engines. So next we're going to move to the bottom end and show you all the differences there. So let's flip these things over and show it off. Alright, more and more changes. So another change that GM made was in the oil pan. So you will notice right off the bat that they went to a doweled silicone style seal around the perimeter of the oil pan with O-rings for where the oil filter passes through. Minor difference, but also you will see that the windage tray is bolted into the oil pan, and rather than the bottom of the main caps like on the LS. Also, you will see that the pickup tube is a part of the oil pan. So there is a O-ring seal that goes between the oil pan, and then the pickup tube bolts into the oil pan rather than like on an LS where it bolts to the engine and then just the oil pan slips over top. So GM got rid of these nice reusable gaskets and opted for a silicone bead around the perimeter to make the pan seal. Of course, they had to change the bolt pattern, so you can't bolt a LS oil pan to an LT. Some of the bolts line up, but almost none of them do. But minor annoyances. Obviously, they had to make room for features that they added. So let's continue to take these apart and we'll see even more differences. Alright, so the bottom end. Not much has changed here. So you'll see very similar architecture. It's a 6-bolt main. Only exception is obviously there's a stud on the outer main bolts so that you can bolt the windage tray to it. But on the LT, they went to a slightly different main cap, but it's about the same. It wouldn't surprise me if it was a slightly different material. Who knows? But the only difference that I can see in the rods is they added this little bump here. What that's for, don't know. Maybe it helps the assemblers to quickly see that the rods have been installed in the correct orientation. Not really sure, but yeah. So one significant change is they added piston oil squirters. So this is a pretty significant upgrade. There's actually people that are taking the LS engines and drilling through, basically through this area of the block to intersect with the main bearing, and basically adding a piston oil squirter to the LS engines. Well, the LT comes standard with piston oil squirters. So another upgrade to take off the to-do list for high output L83s or LT style engines. So one other change that I can see here is they went to a variable output oil pump that is electronically controlled. You'll notice this little solenoid here. This obviously is controlled by the computer, so another minor annoyance. Say if you were to go to port injection and you wanted to use like an LS computer on one of these, you would have to figure out how that guy works and make sure that it's being controlled correctly, or else you may not get adequate supply to your engine, which is very bad. So those are the minor differences that I see. Well, major in the case of piston oil squirter. So you're probably asking, why do we own an L83? So my dad and I, we kind of hit the tail end of the LS craze. You know, we kind of stuck with the small block a little longer than most, and we didn't really jump on board right away. We don't want that to happen with the LT engines. We want to be a part of the LT crowd when it's still new and people may be willing to share information, just because, you know, you teach me something, I teach you something, and we can hop on the train a little earlier and possibly make some waves. So honestly, I think direct injection is the future. Whether you like it or not, this will change the world. So the other reason that we're doing this video right now is we plan to do one of these engines in one of our project cars. So like, comment, subscribe, and when you comment down below, make sure you leave your guess as to which vehicle you think we are going to put one of these engines into. So let's cut this one off here. Catch you guys in the next one. Alright, ladies and gentlemen, times are changing. In a world where...
Restart. Go ahead, just restart.
Well, you can... whatever.
Ladies and gentlemen.
Ladies and gentlemen, times are changing. The EPA has increasing... okay, wow.